Hello everyone, welcome to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Pungodi from CD King Higher Secondary School, Jotsama, Kohima. In this session, we are going to learn how to find the minors, cofactors of elements of in a determinant and the adjoint and inverse of a matrix. Let us learn one by one. Those who are watching for the first time, I suggest you to watch the previous videos first, then you follow up with this video. You will be understanding the basics. Let's get started. Minors, then we will learn cofactors, then we will learn adjoint, then we will learn inverse. Please remember this order. First of all, minors. Minor of an element Aij in the determinant of A is the value of the determinant obtained by deleting its rows and columns in which Aij exists. Let me show you an example. Let us take a matrix A. I'll take 2 by 2 matrix, -1 0 1 2. Okay, here we can find the minor element wise. First let us find out the minor for this element. It is the position of first row and first column, therefore M11. It is in the first row and first column. So what shall we do? We delete this row and column. So we get only 2. That is the minor of this element. And then M12. M12, that is here. This is its position 1 2. Then we delete this row and column. We get only 1. So that is its minor. And then M21, that is here. So we delete this column and row. We get 0. And then M22 here, we delete this row and column, we get -1. These are the minors of the elements present in this matrix A. Okay. Next, I'll show you one 3 by 3 matrix. Let us take A 1 0 2 3 -1 5 2 0 1. Here there are 9 elements, so we will find one by one. This is M11, we are going to get, then M12, the first row, then M13, then M21, M22, then M23, second row elements, and then M31, M32, then M33. Okay, here how should we find? See, first we are going to find out for this element. So you delete this column and row. So we get this 2 by 2 matrix, isn't it? -1 5 0 1. So we will evaluate this determinant -1 5 0 1. Hope you know how to evaluate the 2 by 2 determinant. So you cross multiply, -1 into 1 -1, then minus of this multiplication. We do like this, isn't it? -1 minus of 0. So that is -1. Hope you understand. Then M12. Now for this element. So we delete this column and row. And here we have these 4 elements. Then we will find the determinant of this 2 by 2 matrix. So 3 into 1, 3 minus 10. So 3 minus 10, that is minus 7. minus 7. Then for this element, so we will delete this row and column, we get this 2 by 2 matrix. So we will evaluate this 0 plus 2, 0 plus 2, that is 2, right. Then for this element we delete this column and row and we get 0 2 0 1. If you multiply 0 minus 0, that is 0, right. Okay. Then for this element we will delete this column and this row where it presents, and then we get 1 2 2 1. So cross multiply 1 minus 4, 1 minus 4, that is minus 3, alright. Then for this element we delete this column and this row and we get 1 0 2 0, cross multiply 0 minus 0, 0 minus 0, that is 0, right. Okay. Now for this element we delete this column and row, we get these 4 elements, then multiply 0 minus of minus 2, so that is 0 plus 2, that is 2, clear. And here for this element we delete this column and this row, we get these 4 elements, so 5 minus 6, 5 minus 6, that is minus 1, clear. And for the last element we delete this column and row and we get these 4 elements, cross multiply minus 1 minus 0, minus 1 minus 0, that is minus 1. This is how we find the minors of each element. If you put 1 1, M11, that is minor of this element present in the place first row and first column. Okay. Next we will go to the topic cofactors. Cofactors. Next, cofactors. Cofactors are denoted by Cij or capital Aij. If you put small aij, that represents the element of the matrix, but if you put the capital letter, that represents the cofactor, that is equal to minus 1 plus power I plus j mij. If you know the minors, then you can easily find out the cofactors. See, minus 1 raised to the power I plus j. I is the number of rows, right, in which the element present. Then this represent the column number in which the element present. Okay, let's see this one. This is in the position 1 1, right. So 1 plus 1 is 2. That means minus 1 power 2 into what is its minor? 2. So that is 2, and this will be plus 1, right, into 2. So it will be plus 2, isn't it? So it is very easy to find out. If this addition is odd number, we will get minus. If it is even number, then we get, it will turn to plus, isn't it? So you can easily remember, since you are going to study only the 2 by 2 and the 3 by 3 matrix. So in this way you can remember the sign minus, plus, minus, minus, plus. When you take the cofactor of this position element, you introduce plus in front of it, and when you find the cofactor of this element, you introduce minus, and when you find the cofactor of this element, introduce minus, and here plus, because this is 2 plus 1 3, so it will become minus, isn't it? And 2 plus 2 4, minus 1 to the power 4 will be plus, that's why plus. And for 3 by 3 matrix, it will be right here, the signs will be plus, minus, plus, minus, plus, minus, plus, minus, plus. See, if you remember these signs, then you can easily find out the cofactor with the help of minors. Let me write the cofactors of the same matrix here itself. A11 will be, what is the sign? Will give plus, so plus 2. Then A12 will be, here it is 1, what is the sign? Minus, so minus 1. And then A21 will be here minus sign, so minus into 0. So no need to give any sign for 0, so we can put just 0. Then A22 will be plus of minus 1, that gives minus 1, clear. And for this 3 by 3 matrix, so we will easily find out A11, A12, A13, right. Then A21, A22, then A23, then A31, A32, then A 3 3. Okay, let us introduce the sign in front of the minors. So here we give plus, so plus into -1, -1, and here minus, minus into -7, +7, and here we take plus, so +2, and here we introduce minus, so -0 we can write it as just 0, and here the sign is plus, so plus into -3, -3, and here minus, so minus into 0, so we can just write 0, and here again plus, so +2, and this is minus of -1, +1, and this is plus of -1, -1. Yeah, so we introduce signs in front of the minors to get the cofactors. Okay, then we will go to the adjoint of a matrix, right? Adjoint of a matrix. It is denoted by edge A. It is denoted by edge A. It is nothing but the transpose of the cofactor. Okay, transpose. Otherwise, you can write it as AJI. All right. Let me write the cofactor matrix for this first. That is Aij. That gives us 2 -1 0 -1. Right? Okay. So what is adjoint A? That is adjoint matrix of A. So here 2 -1 0 -1 transpose of this matrix. You know what is transpose of a matrix, right? Interchanging the rows and columns. So that will be 2 0 -1 -1. Okay, 2 0 -1 and -1. All right. Then for this 3 by 3 matrix, let's do it for 3 by 3 matrix. Adjoint A will be transpose of this matrix, isn't it? -1 7 2 0 -3 0 2 1 -1 transpose. Okay, let us interchange the rows and columns. So what do we get? -1 7 2 0 -3 0 2 1 -1. Is that clear? Okay. Minor of an element is obtained by deleting the row and column in which the element presents. Then this cofactor is just introducing the sign in front of the minors, and adjoint is the transpose of this cofactor matrix, isn't it? Then we will go to the inverse of a matrix. Okay, and before we go, I'll give you one shortcut to find the adjoint of 2 by 2 matrix. It is not applicable for 3 by 3, but for only 2 by 2 matrix. For example, 2 0 4 6. Okay, so we can directly write the adjoint matrix of this one instead of finding the cofactors and then taking the transpose. See, what do we have to do? We will interchange these two elements. 6 will go to 2's place and 2 will come to 6's place. So it will be 6 2, and you change the sign of these two elements. Change the sign of these two elements. Here it is 0, so no need to worry about the sign, and here +4, so it will be -4. If it is 1 here, for example, or -1, then it will be +1. Okay, here we have to interchange these two. Okay, and here we have to change the sign. This is for only 2 by 2 matrix to find the adjoint matrix. Okay, it is not applicable for the 3 by 3 matrix. Next, I will give you the formula to find the inverse of a matrix. A inverse equal to 1 by determinant of A into edge A. This is the formula to find the inverse of a matrix, provided determinant of A is not equal to 0. Okay, determinant of A should not be 0. In this case, this A is said to be singular, sorry, non-zero, non-singular. If determinant of A is equal to 0, then we call this matrix as singular matrix. Okay, if A is non-singular, then the inverse exists. That is, it is invertible. Already we have seen what is an invertible matrix. That means it will have an inverse such that AB equal to BA equal to I. Then only we call this A is invertible. Invertible if there exists a matrix B such that, if it satisfies this condition, then we call this B as inverse of A, and A is said to be the inverse of B, right? Okay, if A is non-singular, then inverse exists. If A is inverse, A is having inverse, or A is invertible, then we say that A matrix is non-singular. So it gives us the result A is invertible if and only if A is non-singular. A is non-singular. A is invertible if and only if A is non-singular. Suppose if A is, I will take this first condition, A is invertible, then it satisfies the condition AB equal to BA equal to I, right? Okay, let us take the determinant of this one. Determinant of AB equal to determinant of I, right? Then this can be written as determinant of A into determinant of B, that is equal to 1. See, product of two numbers is 1. So it will never be 0, isn't it? Therefore, determinant of A is not equal to 0. Therefore, A is non-singular. Okay. Suppose if A is non-singular, then determinant of A is not equal to 0, right? If you go through your textbook, you will find one theorem. Adjoint A times adjoint A is equal to adjoint A times A equal to determinant of A into I. This is an important result. You will find it in your textbook. The proof is very simple. You can easily understand. So if you, this is true, we have a theorem, and here divide throughout by determinant of A. So what do we get? 1 by determinant of A into edge A, that is equal to 1 by determinant of A into edge A into A, that is equal to I, right? This is, it looks like this result, isn't it? AB equal to BA equal to I. In this case, this B is this one, 1 by determinant of A into edge A, isn't it? Therefore, this is the inverse. Therefore, A is invertible. So then A inverse can be calculated by using this formula. Okay, I want you people to remember this formula to solve the system of linear equations in the next session. Okay, A inverse equal to 1 by determinant of A into edge A. You know how to find the adjoint matrix and the determinant. The important condition is the determinant of A should not be 0. Then it is called as non-singular. Okay. So in this session, we have learned how to find the minors, cofactors, and adjoint of a matrix and inverse of a matrix. In the next session, we are going to learn how to solve the system of linear equations. Thank you.